Welcome to the Crazy Hat Chemist. So another video in gases. Let's get moving. Bam! So a limiting gas problem. This is like a limiting reagent problem. And you really need to review the previous video in which we had a laboratory setup. There's a similar laboratory setup on this problem, but this is a limiting reagent problem and percent yield. So it's going one step further. All right, so a chemistry student added 0.31 grams of aluminum metal to 112.6 milliliters of a 0.750 molar sulfuric acid solution. And I'm going to show you the laboratory setup on this one. The student allowed the reaction to go to completion. Fortunately, the student collected some data. Here is what was collected. Number one, the temperature at the time of the reaction was 27.1 degrees Celsius. The barometric pressure, the atmospheric pressure at the time of the experiment, was 748.2 millimeters of mercury. 3. The volume of the gas that was collected was 246.5 milliliters. And from a textbook, the student found the vapor pressure of water to be 26.895 torr at 27.1 degrees Celsius. All right, so again, this is a limiting reagent problem. We got a laboratory setup. We're going to show you this. Now, what are we asked to solve for? We're going to first write a balanced equation, so I'm going to step you through this problem. Then the second thing we're going to do is we're going to calculate the number of moles of gas produced. And then we're going to determine the percent yield of the gas from the limiting reagent. So let's get moving on the math part, which is the fun part. Okay, but I'm going to show you the laboratory setup so you have an idea of what's going on, even though it's very similar to the previous problem. Here we go. We got that pneumatic trough like we had before. We had an inverted jar filled completely with water, and via a water displacement, we're going to collect that gas that's being produced inside that Erlenmeyer flask. Excuse me. Here is the balanced equation. I got 2 moles of aluminum, that's a solid, and that's inside that Erlenmeyer flask. I got 3 moles of sulfuric acid, that's H2SO4 aqueous. Those are my reactants. Then on my product side, I got 3 moles of hydrogen gas that's going to be collected. That's our gas that's collected here. And then I got a salt, which is aluminum sulfate. And that's in solution. That's an aqueous solution there. All right, so this inside the Erlenmeyer flask, if you look closely, those little metal pieces are aluminum metal pieces. And this is the sulfuric acid. It's going to be a 3 molar sulfuric acid solution here that I had on this, but in the experiment I added the 0.75 from the information that was given in this lab. And what you're going to do is you have the aluminum in this, and then you're going to pour into this funnel the sulfuric acid right into the funnel, and then you're going to let that reaction proceed on. And that's what you get right there. You should see that inside that Erlenmeyer flask there, you see that white chalky stuff being formed, and that's the aluminum sulfate, that reaction here going. And then you're going to have bubbles inside here, and this is the hydrogen gas in the top part of this reaction flask, that jar that's inverted. All right, so from the information that we got in the lab and then this diagram, hopefully you know what you're doing. So there's that balanced equation again, and I'm going to use the ideal gas law, PV equals nRT. Okay, I'm going to rearrange this to solve for moles of hydrogen just like I did in the previous video. And so moles of hydrogen, that's N for moles, and then P, that's the pressure, V is for the volume, R is the gas constant, T is the temperature. I'm going to plug in the information that I do know, and I do have the volume in liters. It was given to me in milliliters. I had to convert it to liters. Hopefully you're okay with that. There's the gas constant. That's a constant. And I converted the temperature into Kelvin from degrees Celsius. Hopefully you can do that as well. But what I don't have is the pressure of just the hydrogen gas. And in order for me to do that, I need to use Dalton's law again, because this gas is collected over water. Okay, so the total pressure is the atmospheric pressure that's measured, and the partial pressure of water, that's given from a textbook here. I'm going to plug those numbers in. I'm going to get the partial pressure of just the hydrogen gas there. That's 0.9491 atmospheres. I'm going to plug that number into the ideal gas equation. You should see the units of atmospheres cancel out, liters cancel out, kelvins cancels out. I have moles in a fraction in the denominator of that fraction in the denominator of this. That's going to go into the numerator, and I'm solving for moles. And here's the moles of hydrogen. So this is 9.489 times 10 to the negative 3 moles of hydrogen gas that is collected. So this is the actual value that's collected. Remember, this is the measured amount. This is the actual value, okay, the experimental amount. Now I need to figure out what the theoretical amount is collected. Now this is a limiting reagent problem. I have aluminum and I have sulfuric acid. I have a certain mass of aluminum and a certain amount of sulfuric acid. So from those two amounts, I need to figure out which one of these is completely consumed and which one is left over. Okay, so I'm going to take the 0.31 grams of aluminum and convert that into moles using the molar mass of aluminum. Then convert that into moles of hydrogen using the balanced equation there that's on this and using the mole ratio. Okay, then I'm also going to take the sulfuric acid, and I had 112.6 milliliters of sulfuric acid. I used the conversion to convert to liters, and then I used the molarity of the sulfuric acid, which remember, molarity is moles per liter. So I got 0.750 moles per 1 liter, and then I'm using the stoichiometric coefficients of 3 and 3 that's from that balanced equation to convert from sulfuric acid to hydrogen. Okay, now I'm going to get the values here for the production, the possible production from the aluminum of 0.31 grams of 1.7 times 10 to the negative 2 moles. Then from the sulfuric acid, I could get a potential amount of 8.4 times 10 to the negative 2 moles of hydrogen. So the question is, which is the limiting reagent, which is the one in excess? So the limiting reagent is the one that produces the least amount. The one that's in excess produces the potential greatest amount. Okay, so of these two numbers, 1.7 times 10 to the negative 2 and 8.4 times 10 to the negative 2, they're both in the same units of moles and they both have the same formula of hydrogen. Therefore, I can compare the two numbers. So which of these two numbers is the smaller number? Well, first, make sure that your exponents are the same in this case, so that's good. Then you're going to be looking at what's in front of the times 10 to the, and it is the 1.7 times 10 to the negative 2 moles of hydrogen is the smaller number. So therefore, the aluminum is the limiting reagent and the sulfuric acid is the formula that's in excess, or the reagent that's in excess. So you probably want to write that down somewhere. The aluminum is the limiting reagent, the sulfuric acid is in excess. All right, so now I have all the parts to make the percent yield calculation. That is the actual amount, that is the measured amount from the experimental data of 9.489 times 10 to the negative 3 moles, and then the theoretically amount produced, which is the 1.7 times 10 to the negative 2 moles of hydrogen. They're both in the same units, that's moles, and they both have the same formula of hydrogen. So I'm going to put this into my percent yield calculation. I'm going to multiply it by 100, and then here is my percent yield. So it is a 56% yield that I'm going to get on this. So again, this is a limiting reagent gas problem using Dalton's law, using the ideal gas equation, a percent yield calculation. It's an experimental laboratory problem. An excellent problem. You should study this again. Okay? I am the Crazy Hat Chemist, and I'm wearing a hat that you should be familiar with if you take a look at my website. I'm wearing this hat. Give me a thumbs up if you like that video. Subscribe to my YouTube channel, and tell your cat and your dog and your parakeet to subscribe to my YouTube channel too. I'm sure they want to learn some chemistry, especially that parakeet, or that parrot might be able to talk back to you like PV equals nRT and give you a few hints on the chemistry. Bye now.